All right, so now let's take a look at calculating the quantity of heat. The thermal energy, quantity of heat in a substance, depends on three factors. The first factor is temperature. A tub with 42 degrees Celsius water has more thermal energy than a tub with 20 degrees Celsius water. Right? That makes sense. So, thermal energy is proportional to temperature. So that means as thermal energy increases, temperature also increases. And this is a direct relationship. Okay, a bathtub with 40 degrees Celsius water has twice as much thermal energy as one with 20 degrees Celsius. Mass. A full bathtub of 42 degrees Celsius water has more thermal energy than a quarter of a bathtub with 42 degrees water. In fact, this has 4 times more energy than this quarter of tub. So, thermal energy is proportional to mass. So we've got to put this one the other way. As mass increases, thermal energy increases. Right? And as mass decreases, your thermal energy will decrease. In fact, in the first one, I should have put them the correct way, the other way. As temperature increases, thermal energy increases. This is the right way to put it. This first way also works, but it doesn't work for this one. As the thermal energy goes up, the mass doesn't go up. You can't change the mass with thermal energy. Now, the substance matters. When you eat a hot pizza, you burn your tongue on the sauce, not the crust, or the cheese, not the crust. This thermal property is called specific heat capacity, and this also determines the amount of heat energy in a substance. So thermal energy depends on specific heat capacity. And it's a simple number. As specific heat capacity increases, the thermal energy also increases. So we could write that TE is proportional to the specific heat capacity. Now you're like, well, what does this mean, specific heat capacity? It's a number? Yeah, it's a number. And you've got a whole chart of specific heat capacities right here. So you've got a chart. It says density and specific heat of various materials. So the specific heat is over here. It's in a unit kilojoules per kilogram degrees Celsius. You can see air has a specific heat capacity of 1.01. Aluminum has a lower specific heat capacity, so it can hold less thermal energy. Look at the high ones. Methanol is high. Water is very high, 4.18. Sodium is high. So the higher the number, the more heat energy it can hold, the more thermal energy it can hold. Ice and gypsum. Metals are actually very low in their specific heat capacity. They actually hold little heat. Okay, so it's measured in this unit, kilojoules per kilogram degrees Celsius. That means that for water, it takes 4.18 kilojoules of water to raise 1 kilogram of water, temperature 1 degree Celsius. That's what it means. 4.18 kilojoules of energy to raise the temperature of 1 kilogram of water 1 degree Celsius. So if I have a kilogram of water at 50 degrees Celsius, a kilogram of water at 50 degrees Celsius, I put into it 4.18 kilojoules of energy, that kilogram of water will now be 51 degrees Celsius. It will have gone up 1 degree Celsius. Let's take a look. We're going to build the formula. Consider 2 samples of water with the same mass, and both are at room temperature. If more heat was added to one than the other, the temperature would rise more in which one of these? So we've got 2 samples of water. And they're the same mass. We put a lot of heat energy into this one and a little bit of heat energy into this one. Which one of these will go up higher in temperature, do you think? Well, probably the one where the more heat was added. From this observation, we can conclude that the change in temperature in an object is directly proportional to the amount of heat, not inversely proportional. So we wrote this proportion. The quantity of heat is proportional to the change in temperature. Should write it the other way. The change in temperature is proportional to the quantity of heat added. Now let's consider 2 samples of water at room temperature. One sample is larger than the other. So we've got one sample has this much water, and the other sample has this much water. Now we're adding the same amount of energy into both. So I'm adding that much energy into that one and that much energy into that one. In which one would the temperature rise more? The temperature would go up more in this one. If the same amount of heat was added to both samples, the temperature would rise more in the smaller sample. From this observation, we can conclude that the change in temperature in the object being heated is inversely proportional to the mass. So less mass, more change in temperature. So the change in temperature is change in temperature is proportional to the inverse of the mass. So as the mass goes down, the change in temperature will go up. Consider 2 samples at room temperature. One sample is ethylene glycol. The other is mercury. Both samples are 300 grams. Both are given the same amount of heat. The mercury's temperature is observed to rise more than the antifreeze. Both have the same mass and the same amount of heat added. Why did one change more? Because their specific heat capacities are different. Mercury, which is Hg, has a specific heat capacity of 0.14. So this guy's change in temperature is going to be really high. Antifreeze is ethylene glycol. And it has a specific heat capacity of 2.20. This guy's change in temperature is going to be a lot lower. All right, so the bigger this, the smaller the change in temperature. So the change in temperature is proportional to the inverse of the specific heat capacity. Right? The smaller the specific heat capacity, the bigger the temperature change. Now let's write the equation. We're going to write it this way. change in temperature is equal to, it's proportional to the quantity of heat, and it's inversely proportional to the mass and the specific heat capacity. Right, this equation here, I can't see it. This equation right here, the change in temperature is equal to Q over MC. This means as the quantity of heat goes up, the change in temperature goes up. As the mass goes down, the change in temperature goes up. And as the specific heat capacity goes down, the change in temperature goes up. We generally write this formula this way. We take our M and C and we multiply both sides by M and C. And we write it as Q is equal to MC delta T, like that. Now, what are the units of specific heat? Our units on our chart are kilojoules per kilogram degrees Celsius. This means that if something has a specific heat capacity of 1.5, like this is Tecaform, specific heat capacity of 1.5 kilojoules per kilogram degrees Celsius. If I have 1 kilogram of Tecaform, I need to add 1.5 kilojoules of energy to raise its temperature 1 degree Celsius. All right, so that's the basics of the formula. We're going to get into how to use it next.